Hello and welcome to Guessing the Specialist Exam Part 2. Now last year I guessed it, but this year it's these past students. They're super clever. They've started this company. Check them out. The newsletter is awesome. It's got all sorts of cool stuff in it. Let's get started. Alright, so this is the first question. We're going tech active here. So pause the video, get your calculator out, give it a try. Alright, so I'm going to use my calculator for this one right here. I'm in statistics mode and I'm going to intervals, Z, and one sample. Alright, now I think I've already put in my information here because I've been here before. Now we're looking at a 99.7% confidence interval, so that's what I've put in there. A standard deviation of 0.75 and a population mean of 2.5 and a sample size of 250. Let's do it. Okay, now that gives me a lower value of 2.3592 and an upper value of 2.64077. Alright, if I want a margin of error, I need to subtract this from this and divide by 2. I like to do that on this calculator. If you watched my methods video, you'll know why that is. But my answer, according to this, is 0.140, and my answer is D. Alright, that's worth a celebration, and next question. Okay, tech active, we're looking at dominance, matrices. Have a try. Alright, I'm going to do it. This one's annoying because I've got to put it into a little table here. So A, B, C, D, A, B, C, D. A never plays itself, neither does B. Okay, done. Alright, so when A played B, B won. Alright, so B beat A. Alright, C versus D, C won. C versus D, C won. A versus D, A won. B versus C, B won. B versus D, B versus D, D1, D1. Alright, there. D beat B. And then A versus C, A1. A versus C, A1. I've double checked that. I'm happy with it. Everything else is like losses or doesn't exist. So that's all zeros. This is my M matrix, and I need to do M plus M squared. We should type that into our calculator in all one shot. So I've gone in, typed it into my calculator. You can see I've got like a big old matrix here with all those values in it. I've got the same matrix but squared on the end. We can type that in and we get an answer that looks like that. Now in last year's video I just said, now just add these numbers up. 1 plus 1 plus 2 is 4, 5, 2 and 3. But I got called out in the comments because I was told, hey, there's a better way to do that. So if we get our calculator back up and we take the resulting matrix, so on a Casio you just type mat ants like that, and you multiply it by a matrix, a column matrix with all ones, that'll give you your answer. You could have done it all in one shot by just doing like this matrix plus this matrix squared, and then the whole thing multiplied by 1, 1, 1, 1. Alright, and you can see we get the same answer, 4, 5, 2, 3. Which one's faster? Well, I don't know. It depends on the numbers, I guess. Alright, so we're ready to finish our answer. We know that B came first, A came second, D third, and C fourth. Do I have one of those? B, A, D, C, G. I hope the answer is B. Nailed it. Alright, celebrate. Next question. Okay, this one's a good question. Have a little think about it. I don't think I'm going to touch my calculator for this. Alright, let's go for it. It says, determine the general rule for the sixth roots of unity. Now, this is something that notoriously students do poorly in. What does it mean by the sixth roots of unity? Alright, now the word unity is for the number 1. So the sixth roots of unity is like, what is the solution to z to the 6th equals 1. Roots of unity, it's in your syllabus, you're supposed to know it. Alright, now for this one, what you really should be doing is drawing a picture, right? So, the roots of unity are that many equally spaced points on a circle. The first one is here at 1, and the other 5 are equally spaced, so every 60 degrees. 60, 120, 180, 240, and 300. Those are my 6 solutions. So the question just becomes which of those 4, if I put various integer values in for k, will be my answer. And the answer is C. Why is the answer C? Just because? No, look at it, right? If I put 0 in for k, I get cis pi times 0 on 3, which is cis 0, which is this answer. If I put 1 in there, I get cis pi on 3, which is this answer. If I put 2 in there, I get cis 2 pi on 3, which is this answer. 3 pi on 3, 4 pi on 3, 5 pi on 3, etc. Now, there is a big, long, convoluted formula that you can learn for the roots of unity. But what I really want you to take away from this is this picture. Because every year there's questions that rely on an understanding that the nth roots of unity are equally spaced around the circle. And every single time, this is the one that tricks people up. So I really want you to get the hang of drawing that picture and understanding that's what it is. The formula is not that interesting. All right, I'm going to celebrate, and then we're going to move on to some short response. All right, short response, it's tech active. Have a try, and then I'll get into it. All right, so this one's going to be relatively straightforward in part A. I'm really enjoying part B because it really makes you think. All right, so what have we got here? We've got a sample size of 40, a standard deviation of 2, a mean of 35.2, and our confidence interval is going to be 95%. We should just be able to put this into our calculator. So I'm in stats mode. I'm going intervals, Z, one sample in specials where we're looking for the confidence interval for the mean. Okay, so what have we got? A confidence level of 0.95. We've got a standard deviation of 2, a mean of 35.2, and a sample size of 40, and that is where we're at. Okay, so our confidence interval for the population mean is 34.58 to 35.82. Okay, so what does that mean? We are 95% certain that the population mean is between these two numbers. That means we're going to be wrong 5% of the time. It's going to be outside of those numbers. So the more interesting part of this is part B. What would happen if the sample size was increased, and what would happen if the confidence interval was decreased? All right, let me get rid of this. I'll just keep this and then we'll move on. All right, so first let me give you the short answers with like intuitive solutions. All right. What would happen if the sample size was increased? So if n goes up, what happens? Well, if we get more and more and more samples, right? Imagine if we just surveyed the entire population, right? Well, our confidence interval, if we surveyed the entire population, our confidence interval wouldn't exist. We would just know what the sample mean was, right? So we can say that as we make our sample size larger and larger and larger and larger and larger, our confidence interval shrinks in size. Now, I'm trying to give you an intuitive understanding of that before I jump into like mathematical justification, because this idea is often a feature of multiple choice questions. If you increase the sample size, what will happen to the margin of error? It will get smaller. What will happen to your confidence interval? It gets smaller. All right, what happens if the confidence interval was decreased? Okay, so what if you didn't want to be 95% certain? What if you only wanted to be 80% certain? Okay, this one tricks people up. As your confidence interval decreases, as you have less confidence, your margin of error gets, suspense, smaller as well. Your margin of error gets smaller, right? Because at the moment, to be 95% certain, I need the boundaries to be here and here. If I want to be less certain, right, I can make it much, much smaller. And I can say, well, I think it's only between 35 and 35.2. Now, if I'm saying 35 and 35.2, more of the things that were in here are going to be outside of that. So I'm not going to be right 95% of the time. I'm going to be right like 50% of the time. All right, so these are my kind of intuitive, this is how I think about it. But this doesn't feel like good mathematical justification. It's no justification at all. In order for me to justify this, I'm going to need a little bit of help from my formula sheet. And so what I think I'll do is sub in all of my information into my formula. There's my formula as it currently stands. And now let's look at what happens when we increase the sample size. For the sake of argument, let's increase the sample size by a factor of 4. And you'll see why I'm choosing to increase it by a factor of 4. If I increase it by a factor of 4, this number doesn't change, this number doesn't change, but this number becomes root 4 times 40, right? And the reason I'm choosing this 4 here is because now I can pull that out of the surd, which means that it's not 4 times 40 anymore. It's 2. 2 over 2 root 40. Okay, so what does that have the effect of doing? It has the effect of halving my margin of error. If I quadruple my sample size, I halve my margin of error, and therefore my margin of error gets smaller. I'm not going to formalize a bunch of working here because then I'm going to have to write a bunch of words and things like that. But I want you to understand the basic premise here. There have been some really nice questions in the past where they don't give you any numbers at all, but instead they ask you what would happen if you quadrupled the sample size, for instance. And then you can use this idea to say, oh, well, if I quadruple it, that means that I'm halving my margin of error. We can sort of think similarly, we can justify mathematically similarly when our margin of error, when our confidence interval is decreased. So again, this is what our confidence interval originally looked like. If our confidence interval was decreased, if we didn't want to be 95% confident, if we only wanted to be 90% confident, this 1.96 becomes 1.64, right? And that is going to decrease the size of my margin of error, which is going to shrink my confidence interval. So again, we're kind of showing by example that increasing the sample size or decreasing the confidence interval. There are more rigorous ways that you can do it, where you can show that as you increase the denominator, you decrease the value of this entire thing. But I think that by example is probably enough mathematical justification in this example, given that they are giving us all of these numbers. If they weren't giving us numbers, if they were just asking these things, mathematically justify why the sample size was increased, then we'd have to be far more algebraic with the whole thing. But I think what I'm describing here is enough for part B here. I'm going to celebrate, and I'm going to move on to the next question. Before I move on, I sort of want to justify why I'm being deliberately vague here, right? My job here today is not to guess the exam, not seriously. My job here is to prepare you for the exam, and I'm talking to you about it, right? What I'm really encouraging you to do, check this out, is think about what you're doing. All right, next question. Everyone's favourite. Okay, have a try at this one. I've got a part A, B, and C. I think I've also got a part D. I do. So I'll put that up there. You can try it yourself, and then I'll get started. All right, let's get rid of part D because it's a big one. Let's deal with part A, B, and C. Construct an initial population matrix. I like questions like this because this is how a table might be shown to you, right? And then you've got to translate it into like some mathematical dealing. All right, initial population matrix, that feels super straightforward. The population matrix, 0, 1, 2, 3. So we need 4. So we need 100, 250, 120, and 50. Part A. Done. Part B, construct a Leslie matrix. Okay, now along the top here, this is where we put our birth rates. All right, so 0, 1.5, 1.2, and 0. Now, the rest of it's almost all zeros, but our survival rate goes along a diagonal, starting here, right? So survival rate, 0.97. The rest is zeros. Okay, there's a 0 there, and then diagonally 0.53, and a 0 there, and 2 zeros there, and then the last survival rate 0.27, and then a 0, and a 0. Done. Okay, so step part A, part B, part C, predict the population distribution after 10 years. Now you should write all of this down, so I'll just write the shorthand version of this. So after 10 years, it's going to be equal to the Leslie matrix raised to the power of 10 times the population matrix, the initial population matrix. Calculator. All right, I've typed all this into my calculator off screen. I don't think you want to watch me do that. If you do, let me know in the comments and I'll start doing it from now on. All right, so if I press enter on that, I'll get this answer right here. Okay, I've written all of it down. Let's get rid of our calculator. Okay, so every year people ask me about rounding, and so I'm going to give you my opinion, and it's the correct opinion, on how you should round this, right? If you're asked for like how many, what are we talking about here? Amphibians. How many amphibians are 0 years old, right? Do not feel like you have to round up. Do not feel like you have to round down. Just round normally, right? This is a prediction of the future, and it says 6179.12. It's not like, oh, someone's halfway through giving birth or something. This is just a prediction. We just round, and we assume that we're going to have 6179. We round here, and we're going to have 4457, okay? If you're asked for the total population, just add all these numbers up, decimals included, and like everything just averages out in the wash. Think about what you're doing. You're predicting the future. This is not like an actual like calculation. If this was a different question, like not a population, but like some sort of like, I don't know, a compound interest question where a bank was putting money into your bank every month and you wanted to know like on what month, you would have to round up because the money comes into your bank account at that time. This is a rant. Just don't overthink this. Just round normally. All right, I went and had a lie down. I'm back. Let's do this. Part D. Now, I've put just the important information here. Now, it says that the whole game started in 2021, right? And everything's fine for the first 2 years, up until 2023. But in 2023, a new predator arrives, and that changes the game from 2023 to 2030. Okay, so everything's fine for 2 years, and then the game changes for the next 7 years. All right, so first of all, we need to figure out what our population is in 2023. So that's going to be relatively straightforward. Leslie matrix squared, P. Our calculator will give us that. Okay, I put it into my calculator and that's what I got. You'll notice I'm not rounding, but I'm not going to go into that again. I'm staying how I am because I'm in the middle of things. Okay, then what happens? It says, consumes approximately 30% of the newborns. Okay, what does that affect? It's affecting the survival rate of the 0-year-olds, right? At the moment, the survival rate is 97%. I'm taking this to mean that of those 97% that would normally survive, 30% of them get eaten. So I don't think it's as simple as just decreasing this number by 30%. But like just writing 0.67, just subtracting 30%. I think we actually have to do 0.97 times 0.7. So like of the 97%, let's find out what 70% of that is, because that's what will survive. 0.679. So that's the only alteration I think I need to make. So now what I'm going to do is do my Leslie matrix calculation again. with like 7 years, so L7, but like this new matrix now, let's call it like L1 now, right? And then multiply that by the population in 2023. So we'll just call it like P2. This is P2 here, right? All right, so we need to do this new matrix to the power of 7 multiplied by the new population matrix. Okay, I put that into my calculator and I got this. Again, all those decimals, but if I add them all up, I get this number here, and this is where I would be rounding, 3229. Okay, we can finish off this question by saying, don't worry about the amphibians, they're not endangered. In the year 2030, there will be 3,229 approximately. That's much more than 500. Done. You should write that in a sentence. I think that is worth one of those. Alright, so this has been part 2 of Guessing the Specialist exam. Thank you very much to my great past students. Go and check out the website if you haven't already. It's not too late. They cover all sorts of subjects, not just maths. I highly recommend. Go check it out. Practice, practice. Catch you in the next one.